So we can do a couple of things with this. This notation is very powerful, okay? You can use it to generalize things. For instance, if we go back to Pascal's triangle, if we go back to this guy, I want us to redraw him. What would he look like if we used this notation? Well, I'm going to redraw him, and I think you should too. You don't need to redraw a lot. Ooh, wait. No, I want to leave that one there. I'll do it over here. Have you guys written what's in red? Have you got that? Can I rub it off? Thank you. That very first number up the top, in your diagram and in mine, we labeled that as the 0th row, okay? So that would correspond to 1 plus x to the power of 0. Do you remember that? Okay, so it's the 0th power and the 0th coefficient, which was 1. The next one is the first row, right? So this 1 corresponds to 1C0, and then 1C1. And then I do the second row. And then I do the third row. You can see what's going on here. I'll do one more, and then I think that'll be enough to pause. Okay, now from this, I want you to go back to the list of properties that we pointed out before, when we were just looking at this and having a look at some of the numbers, okay? We can rephrase all of those, well, most of those properties in terms of this language in a more sort of elegant, concise way, okay? I'll give you some examples. Have a look at the outsides of the triangle. We didn't actually name this because it seems so obvious, right? But now using this notation, it's less obvious. Having a look at the outsides, all of the numbers on the outsides are all 1, right? But now, have a look at what this new notation tells you, right? All of these terms out here are n choose 0 on this side, right? And n choose n on this side, right? So now here's a property. This is properties again, but in NCR notation. Okay. I can say that n choose 0 or n choose 0. That's all of these guys on the left. Okay, they're all equal to n choose n, which is all these guys on the right, which is equal to 1. That's a property, and I can say it algebraically in an actual equation. Okay, and we also said there's symmetry to this, right? Symmetry. This number matches this number. This number matches this number. How would you say it in NCR notation? How would you describe the symmetry? Okay, if I picked out some term, the rth term, okay? Suppose this was the rth term. This would be r equals 0, 1, 2, okay? Which term does it match up to? In here, this is the 7th row, right? So I'm thinking this is 7 choose 2. It matches up to this guy. This would be 7C3, C4, C5. 7, 5, right? These two match. Is that okay? Let's try another one. How about, say, down to here, okay? This would be row 9, right, 9. And this would be term 0, 1, 2, 3. Or I could say, if I had 1 plus x to the power of 9, it would be the third coefficient along, right? And you see, which number does it match up to? And the answer is this guy over here, 3, 4, 5, 6. Now these are all concrete numbers. Can we generalize? Can we abstract? What's NCR going to be equal to? Which term does it always match up to? It's in the same row, right? So it's still going to be n. What's the number down the bottom? 2 and 5, they add up to n. 3 and 6, they add up to n. It's n minus r, isn't it? Okay, that's the symmetry property, but in notation. Okay, does that make sense? There's other things. What other properties we have? We had all of the terms added up, right? They're always a power of 2. How can we write that? How could I write that? Well, if I want to name all of the terms, n choose 0 is the first one. The next one will be n choose 1, nc1, nc2, and so on. What will be the last one? ncn. And they all add up to 2 to the power of n, because I'm in the nth row. Look, 2 to the power of 6, 2 to the power of 6, 5 to the power of 6, 2 to the power of 7. Okay, it's 2 to the n. This is another reason why it's good to start off with this being the 0th row. Can you see why people are just trying to make maths hard for you? Like, why start with 0, right? Because 0 makes sense mathematically. This is the 0th power of 2 and the first power of 2. And then you get the idea. Okay. 2 to the power of n. That's 3. There was another property. What was the property we started with? It was the addition property. Ooh, okay, this is a bit trickier. You need to think hard for this one. Let me give us some more room. How are you going to explain, how are you going to articulate the addition property in terms of all of this stuff? Well, the addition property means, in order to get to a term like this, the place we got it from were these two terms. Right? So this term here, I'm going to call him and choose R. Right? Arbitrary N, arbitrary R. Now where did I get him from? I went to the previous row and I took those two. Right? I should stop pointing and I'll just put colors on. Okay. 1, 2, 3. Okay. So from row N, I've got to climb up one to row n minus 1, don't I? That's where I have to go back up, right? So that's equal to n minus 1 plus n minus 1. These are two terms from the previous row. Which two terms? If this is R, right, then it's going to be R minus 1 and R. Does that make sense? This is the addition property. Now, it's worth noting, this is not the only way to write the addition property. I can write it in a couple of different ways and it's still the same property. I'll give you an example. Suppose I didn't want to go up. I didn't want to think about up. I want to think about down. How do I do the next row? Okay. Well, let's start with, say, these two. How do I go from these two to this one? Okay. If we call this our starting point, right? Call that guy, sorry, this is OR. The same property, okay? Call that guy NCR, okay? What's the guy next to it? NCR plus 1, that's the difference. Same row, different number, pushed over 1. Okay, which number do I get when I add these two together? Well, I go down a row, so this will become n plus 1. And then which term along do I get? And the answer is, I get this term, don't I? That's the r plus 1th term along, okay? Now can you see, these two look quite different. Like the numbers are all mismatched, but they're the same property looked at from two different angles. I could do it from a couple more different angles, depending on which number I start with, okay? But you get the idea and you see where it comes from, okay? Okay, let's see. A couple of things to finish. Now going to this n and this r business, I'm going to write out 1 plus x to the n, okay? What's it going to be equal to? Start with the 0th term, right? Then the first term, then the second term. What will the last term be? It's going to be this guy, n, choose n. And what will the power of x be? It'll be n, won't it? Okay, now that's a bit long and awkward and I have to have a ... because I have no idea how many terms there are, okay? But we've learnt language to describe this already. When you're adding up a whole bunch of things and you have to increment along to get all of them, and you know how many there are in total. How many terms are there in total? You started at 0, so there are n plus 1 terms. When you want to add up a whole bunch of things that are separate, we use sig notation, don't we? That's how we do it. It's a far more concise way to say it. How do I define it? I need a starting point and an end point. You could say I need a lower and an upper bound, right? What's my lower bound? Where do I begin? I start at 0. And then I end at n. 0 to n gives me the n plus 1 terms, right? Okay, so that's how many I've got. What does each term look like? What do I put in here? It'll be NCR, like that. Okay. which power of x am I going to get? Think carefully, think carefully. What this represents is the rth term. I go from r equals 0 to 1 to 2 to 3 to 4 and so on up until n. So which power will I get? I'll get the rth power because it has to change. It goes 0, 1, 2, 3, etc. Right? It's not x to the n because there's only one x to the n. There can be only one. You get the idea. Okay? So there you go. That's the general term there. Okay? Okay. This big notation idea, it takes a little bit of time to wrap your head around, and especially like when you look at this, believe it or not, some people get their introduction to their first words out of the teacher's mouth for but underneath the heading binomial theorem is this list of properties, and you're like, are you serious? I hope you can see it basically comes from here. That's where it comes from, okay? So if you can see this when you look at this, then you'll nail it and you won't mix up your n's and your r's and your n minus ones and so on, okay?